Intelligent, comfortable, and autonomous. That's how we imagine the transport of tomorrow. But is it really the automobile that will drive us into the future? One vision of a new mode of transportation seems promising: the Hyperloop, a train capable of reaching the speed of sound. While some say it's a crazy idea, researchers and entrepreneurs from all over the world are working on making the Hyperloop a reality. Should we remain faithful to old concepts of mobility or embark on an uncertain future? Los Angeles, the city of dreams, is the birthplace of a vision that could revolutionize our speed of travel. The Hyperloop. A train that races through a vacuum tube. The idea came from billionaire Elon Musk. He earned his fortune from online businesses. Today, he makes electric cars and is designing a rocket for interplanetary travel. But he doesn't want to design the Hyperloop himself. Instead, he decided to organize a competition for students from all over the world.
So what this is really intended to do is to encourage innovation in transport technology, to get people excited about new forms of transport, things that may be completely different from what we see today.
A team from Munich are also taking part in the competition. The students are determined to be involved in the mobility of the future. They're up against teams from all over the world. Which one of them will build the best Hyperloop prototype? Over 400 student teams submitted a design. The 27 best teams were invited to build their prototypes and compete against each other for the first time. Students from the Technical University of Delft in the Netherlands were the second European team to qualify for Los Angeles. All the others from Europe were eliminated at an earlier stage. It's hard to imagine that the transportation of the future might be born in this open-air workshop. Around the world, traffic is predicted to grow. More and more people are traveling ever greater distances, doing business and venturing to every corner of the globe. But our transportation infrastructure is not designed for a society that is forever on the move. For Michael Schreckenberg, this is a worrying development. Our expectations no longer match the reality of what is feasible or our ever-dwindling resources.
People expect to be able to be mobile at all times, which means being able to use their vehicle at any time. They expect the infrastructure to be available, and they expect the energy to be available too. This has become our basic mentality, and if this mobility becomes impossible, we'll see problems. In the future, we'll have to live with the fact that resources are limited.
For many young people, owning a car is no longer as important as it once was. But rising prosperity and population growth mean that the number of cars continues to increase around the world. As a result, our roadways are under strain, and there is more and more road construction and congestion.
Statistically speaking, a car is parked 23 hours a day. That means it's an underutilized asset that I could invest better somewhere else. car sharing and public transport are better alternatives. There are various concepts, but in the end what matters is whether people and drivers go along with these concepts.
One of these concepts could be the Hyperloop. The idea isn't new. The basic principle behind the Hyperloop has been around for well over 100 years. It's based on a system of transport that was designed not for people, but for letters and documents. The pneumatic mail tube. In New York City, a large network of pneumatic mail tubes once connected entire districts. These tubes also delivered mail within buildings, from one floor to the next. Placed inside capsules, documents were propelled through tubes at speeds of up to 40 kilometers per hour, using compressed air. The capsule fits so snugly in the tube that no air can escape along the sides. Air is sucked out of the tube in front of the capsule, creating a suction that propels it. The Hyperloop also relies on this concept. It also moves through a tube out of which nearly all of the air has been pumped. In this near vacuum, the capsule is subject to very little friction. Only a small amount of air remains in the sealed tube. Just like in an airplane, passengers would travel in a pressurized cabin that also contains air. Otherwise, passengers wouldn't be able to breathe. Removing most friction and air resistance would allow the Hyperloop to travel at very high speeds. At 1,200 kilometers per hour, it could shuttle from Paris to Berlin in around an hour. So far, this is only theory, but Dirk Alborn wants to prove that it could work in practice. Several years ago, Alborn founded a company in Los Angeles. It's just one of a number of startups working on making the concept a reality. Right now, though, it's little more than an idea. Alborn's startup is looking for investors. Potential investors have shown how a Hyperloop would work by way of models. One of the main concepts is the principle of magnetics. Magnets play an important role in two key aspects of the Hyperloop. The capsule floats with the help of magnets, and magnets help propel it. The bottom of the capsule and the floor of the tube are both equipped with magnets. When the capsule moves across the floor of the tube, it generates a magnetic field. Both magnets have a south and north pole. The two south poles are facing each other. Because like poles repel each other, the capsule floats. A kind of aluminium fin is used to propel the capsule. The fin runs along a track made of magnetic coils. These coils can be activated with electricity. They then also generate a magnetic field along the aluminium fin. The magnets in the track repel the capsule forwards, and the entire capsule moves forwards through the tube. It's a complex technology and many questions have yet to be answered. To iron out the kinks, Alborn's startup is relying on a kind of swarm intelligence. While the company does have a headquarters, its staff is spread around the world and collaborate virtually.
After I founded the company, we gathered a small team. We told them, anyone who wants to be part of this and is willing to devote at least 10 hours a week to the project, let me know. In exchange, we'll give you a share in the company in the form of company stock options. We received about 200 applications. We selected just under 100 engineers who are collaborating with us on a feasibility study.
The students from Munich found a temporary workshop in Los Angeles where they can put together their pod after transporting it to California. They still need to qualify for the run through the test track. That means putting the prototype through its paces to show it can handle the final round. As they start building the pod, they realize that crucial parts are missing. They were held up at customs. Without these parts, they won't make the final round. But there's still another week to go. For the students, working on the Hyperloop is a hobby. They don't get class credit for it or a salary. Only the cost of the actual prototype is covered by sponsors, such as Airbus. For the students, this is an investment in the future. They want to be part of a dream, designing the transport of tomorrow.
People have always had ideas for how to speed up travel. People dream of making a quick trip to Australia for dinner and returning home later that same evening. To be able to transport yourself from one place to the next at will, to shrink the world, as it were. Even today, we still have that dream.
In 1867, the inventor Eli Beach had a similar dream. He wanted to build an underground commuter car in New York City that would use air pressure to glide through a tube. But the city would only authorize a pneumatic tube system for mail, not for people. Eli Beach continued with his project in secret. He was able to prove that the concept would work, but the city still refused to authorize his system. Instead, it opted for a different technology that could also operate above ground: the railway. For nearly a century, it was the most important form of travel in the industrialized West. But the technology requires a great deal of infrastructure: railway tracks, signaling and control systems, and railway stations. Eventually, the automobile took over as the most important means of transport. Automobile manufacturers have become extremely powerful, and they're loath to give up their upper hand. But congested roads, pollution, and the cost of fuel have made cars less and less attractive. As a result, automotive manufacturers are starting to come on board with new concepts. In the future, mobility, digitalization, and marketing could all go hand in hand. Our car could fulfill our every desire, even ones we can't yet imagine.
Guten Abend, Isabel.
Good evening, Isabel. How are you?
Great. Why?
Ihre Vitalwerte sind
Your
niedrig.
vital signs are low.
Möchten Sie einen Kaffee?
Maybe you'd like a coffee.
Ihren Kreislauf
That will
entspannen.
help perk you up.
No, thanks.
Der Umweg
The
beträgt
detour is 1.37 kilometers. You'll be on time.
nach Ihrem Termin.
It's too late for coffee.
Dann vielleicht ein
Then perhaps a vitamin drink or a protein shake.
Okay.
The problem in traffic is not usually the technology. The technology is easily available. The problem is people themselves. And the question is how people use technology. Who wants to read a 500-page car manual just so they know how to operate all of the systems it comes with?
Semi-autonomous driving systems that allow for hands-free driving are already on the road. Drivers are supposed to be ready to take over the steering wheel at the blink of an eye, but many drivers don't take that seriously. They post videos of what they're doing on their journey online. But when it comes to avoiding collisions, the autopilot system on these cars can only handle a single scenario. That's not enough to handle complex traffic situations. In May 2016, the autopilot function on a Tesla Model S caused an accident. The driver didn't have his hands on the wheel, and he was killed in the accident. Joshua Brown was the first fatality involving a self-driving car. His car hit a tractor-trailer without braking. The truck was visible for several seconds, enough time for a driver to respond. Normally, the autopilot function scans the lane right in front of it. If it detects an obstacle on the road, it activates the brakes. This works well on motorways that have no cross traffic. But the truck approached from an intersection. The Tesla scanned the lane, but the truck had such a large wheelbase that the autopilot registered the lane as intermittently empty. The sensors did detect an intermittent obstacle, but misidentified it as a traffic sign overhead.
The sensor technology in self-driving cars today is mainly intended for highway operation. It can't provide a good overview of what's happening in complex intersections. And maybe it will never be ready for that. To do that, it would need much greater detection capabilities. It would need to detect and understand cross-traffic even before it becomes visible. Unfortunately, drivers believe that the cars are already capable of all of that, as we saw in the Tesla accident.
In Los Angeles, the team from Munich has arrived at the competition site. Lucas and his teammate Thomas are checking out the competition. The last parts they needed for their own prototype were finally released by customs, and they're ready for their first test run. If they succeed, they could make it to the final round of this competition. They've overcome the first hurdle.
Our secret weapon is the compressor. We're one of the few teams using a compressor like this. It sucks the residual air out of the tube. The partial vacuum in the tube has 1/100th of regular atmospheric pressure. The air friction would slow down our pod. To prevent that, we'll suck the air out. Then we can travel fast without air resistance.
The next step is attaching the magnets that were released by customs onto the prototype, the pod as it's called.
The magnet is used to make the pod float. It's screwed onto the underside here, and as soon as the pod reaches 180 kilometers per hour, it creates a lifting effect that lifts up the pod.
The test track is too short to accelerate the pod on its own. So it will get some help from a pusher cart that will get the pod up to speed so that it can levitate. If the Hyperloop becomes a reality, it would be particularly useful in areas without much existing traffic infrastructure. The fastest route from San Francisco to Los Angeles takes you through the middle of a desert. It's a 6-hour journey by car. The only alternative right now is air travel. With the Hyperloop, the journey would take just 36 minutes. And the energy for the Hyperloop could in theory be delivered by solar cells on the roof of the tube. The energy generated by braking could also be stored.
The entire system is completely eco-friendly. But that's not simply because we want it to be eco-friendly. Particularly when it comes to the field of alternative energy, the true advantages become apparent when we deploy that alternative energy to our own advantage. So in our case, we'd put solar cells on the route along the entire infrastructure. In California, we could generate all the energy we need simply using solar power. Then there's also wind and kinetic energy. That would keep our operating costs so low that we'd be able to generate a profit.
The
Hyperloop is a form of technology we could actually make happen today. But there are also many other technological developments, including in Germany, that might also have been feasible. The Transrapid could have also worked. It's not quite as fast, but the technology already exists. We've already seen an example that demonstrates that this technology is indeed feasible.
The Transrapid was a high-speed monorail system that used magnetic levitation. It was developed in Germany. A testing site for the Transrapid went into operation in Emsland in western Germany in the mid-1980s. The Transrapid didn't glide through a vacuum tube, but it did use magnets for propulsion. The maglev train had a top speed of 412 kilometers per hour, faster than modern intercity express trains in Europe. On September the 22nd, 2006, in the middle of its test route, the Transrapid collided with a maintenance vehicle that was mistakenly on the track. 23 people were killed and 10 were injured. Today, the former test track lies in ruins. After the accident, the German Transrapid could no longer find an investor. However, the system went into operation elsewhere. In Shanghai, a maglev train went into public commercial service in 2004.
The Transrapid was ahead of its time. It was one of the first systems of its kind and was regarded as a failure. But when you make a mistake, you should use it as a learning experience and carry on. For whatever reason, that doesn't happen in Germany. Instead, we always feel a kind of shame for our mistakes, for our failures. That's exactly the wrong approach. Mistakes are part of every development process. If I'm not willing to make mistakes, I won't be able to build a better product.
When it comes to safety, the Hyperloop is still in its infancy. At the competition in Los Angeles, the prototypes are tested for safety. But they're nowhere near ready to transport people. The pods have just enough technology to navigate their way through the tube. The students haven't yet attempted to build a pressurized cabin. The pressurized cabin is the weak point. If it were damaged, the passengers would be exposed to the vacuum.
It's kind of like the airplane claustrophobia and depressurization problem amplified, because you have no windows, and if it depressurizes, you're definitely going to die. So we need ways to mitigate those problems. I think having a comfortable cabin that is spacious and stuff can help deal with claustrophobia, and there definitely need to be safety systems to deal with depressurization and emergency evacuation. So those are problems that need to be solved.
Another challenge is the speed, up to 1,200 kilometers per hour. Can passengers even handle such high speeds? Nowadays, fighter jet pilots can travel at speeds of up to 3,000 kilometers per hour. They train hard to handle the stress on their body and wear protective gear. The problem is not the high speed as such, but the acceleration and deceleration phases. Takeoff and landing put a major stress on the body. The Hyperloop doesn't ascend and descend. It gains speed at an even pace and maintains that speed. For passengers, it would probably feel much like a commercial airplane. But it would certainly take some getting used to, particularly because of the vacuum tube.
There is always some element of danger, but that's already the case with airplanes. They aren't in a vacuum, but they also deal with low air pressure. We just have to try out and then continue to develop it until it is safe. For example, we could first use the system to transport freight, so people wouldn't be at risk. Then when we see the system is safe, we could start to transport people.
Today, international trade relies mainly on container ships. Compared to the Hyperloop, they're unbelievably slow. Large container ships have a top speed of just 23 knots. That's around 42 kilometers per hour. Freight transport is already seriously overburdened, and in the coming years, the transport of goods is expected to rise by 38%.
The problem with freight transport is that a system like the Hyperloop would only be worthwhile for transporting goods for longer distances, say 300 kilometers. And the kinds of goods it could transport would be very limited. It wouldn't be able to replace most freight transport. Because of its high speed, it might make products easier to deliver over large distances. But even that would do little to solve our overall problem when it comes to freight transport.
Plus, a freighter can transport up to 20,000 containers at once. A Hyperloop could only convey a single pod at a time. That's why transportation experts are investigating ways to use roads more efficiently. In truck platooning, several trucks travel in a column. They're connected through Wi-Fi and respond in concert. The first truck in the chain guides the other vehicles, which save fuel by remaining in the slipstream. In theory, passenger cars could join the convoys. Maintaining short intervals between vehicles that respond simultaneously could help prevent traffic jams. A driver in a passenger car would send out a request to join the convoy. If the leader accepts the request, it would assume control and handle steering for the new arrival. The car journey would be similar to a train ride, with one important difference. Platooning relies on a functional Wi-Fi linkage. The benefits of platooning only emerge when a large number of cars are linked and can communicate with each other. For that, car manufacturers would still need to design a unified standard. At the German Aerospace Center in Braunschweig, scientists are investigating the technology this would require. They are designing a car that could become a data center, a kind of smartphone on wheels. GSM communication standards, UMTS, and GPS allow the vehicle to send and receive signals. The researchers want the vehicle to be able to independently communicate with its surroundings. That could be a breakthrough, a large step forward in ensuring safety in autonomous and self-driving vehicles. The scientists want the vehicles to communicate with each other and with their surroundings. For that to happen, every element of the road traffic needs to speak the same language. The researchers have already put the first step into practice, installing intelligent traffic lights in central Braunschweig. These traffic lights signal to vehicles how long the light will remain green. The vehicle knows exactly when the traffic signal will turn red. Early field studies have proved promising. In the future, the vehicle will be able to identify where other road users are located. In this highly linked environment, the vehicles would also be able to identify pedestrians. There would be a continuous flow of data identifying everyone on the road. Researchers believe this could make traffic much safer.
One of the most promising projects for the future is networking. This would allow vehicles to communicate with each other and allow us to continue to reduce the human factor. Vehicles would be able to operate in harmony thanks to the use of algorithms. For example, they could agree among themselves how to join a flow of traffic. We'll see this happening in the future, and we'll see vehicles take over more and more functions. In the end, the main thing that disrupts the flow of traffic is people.
In Los Angeles, the competition is about to get underway. It's the moment of truth for the students from Munich. Their pod is getting ready to launch. The test track is 1.5 kilometers long. In theory, the pod could reach a speed of 350 kilometers per hour. Most of the other teams have failed to pass the initial phase of the competition. They won't be permitted to put their pods to the final test. In some cases, their technology wasn't sophisticated enough. Other teams just couldn't get ready in time. In addition to the Munich crew, only 2 other teams have qualified for the final round.
The problem is that the SpaceX pusher cart had a software failure or something. It's not working the way it's supposed to.
If the pusher cart doesn't get the pod up to speed, it won't manage to levitate. The magnets only function when the pod reaches a speed of 180 kilometers per hour.
We decided not to use the magnets after all, because we're not getting fast enough with the pusher cart to levitate. And the magnets create a lot of drag, which would slow us down. So we're leaving them out for now and trying to be the fastest team, very fast, even if we're on the wheels.
The team from the Netherlands goes first. Their prototype is unusually sophisticated. But they also struggle to cope with the defective pusher cart. The acceleration isn't enough. The prototype from the Netherlands comes to a halt halfway down the route. The next team is from MIT, the renowned Massachusetts Institute of Technology. They're the favorites today. Everyone expects them to win. But their pod also stops halfway. Now the team from Munich are up. They wish the levitation would have worked, but they're determined to still get as far as possible down the test track. The amount of friction the pod generates in the tube will make all the difference. The rest is out of their hands. The prototype gets off to a good start. It's the only pod to reach the end of the test track. It's not quite the speed of sound, but it's enough to win in the speed category.
It was a run of glory. Winning one of the main prizes is really just... I'm speechless. It's really great.
The prize for the fastest prototype goes to the team from Munich. Does the Hyperloop stand a chance in Europe? Toulouse is an important centre of technology. The city has a lively startup scene. It's part of a French high-tech initiative that provides support to innovative companies. Now, a research centre is in planning, which is intended to promote the development of a Hyperloop in Europe.
Europe is particularly interesting because we have shorter distances here. The Hyperloop system is perfect for distances where the travel time is around 40 minutes to an hour. That's especially interesting at a time in which Europe seems to be falling apart a bit. It's one way we could bring people together more.
Alborn has signed a contract with the city of Toulouse to establish his research centre here, even though his company has yet to build a functioning prototype. No decision has been reached whether France will venture to build a Hyperloop network. In a city like Paris, A Hyperloop would only be feasible if the station were easily accessible. But most cities already have a central railway station. Traffic routes to the outskirts of the city tend to be overburdened and congested.
If we build something that takes you from Los Angeles to San Francisco in 36 minutes, or from Paris to Berlin in little over an hour, but it still takes an hour and a half to get to the station, then you haven't really changed anything.
Bis du im Bahnhof bist, dann haben wir nicht wirklich was geändert.
The Hyperloop could only succeed if all transport systems become more efficient and if the various means of transport are synchronized with each other. The Hyperloop pod belonging to the students from Munich is on exhibition. It serves as inspiration for the next generation of students who will be taking over the concept. They'll be revising the design for the next round of the competition in Los Angeles. On their next outing, the students want to make sure their pod reaches the speed necessary to levitate. They're experimenting with ways to do without the pushing cart. That was what failed during the first competition. The solution could be another mode of propulsion. A small and extremely lightweight electric motor that could propel the pod to the necessary levitation speed. The entire prototype can't weigh more than 80 kilos. So the pod itself needs to be slimmed down. The team decides in favor of a lightweight braking system that weighs just 4 kilos. It's just one of many decisions they'll have to make, and they're still working on a prototype. There's no telling when they'll be ready to build a fully functional vehicle. In many countries, existing rail networks have already reached capacity. The TGV in France has its own dedicated rail network. In Germany, though, the intercity express trains share the tracks with regional and freight trains. When a regional train is delayed, it can have a knock-on effect across the entire country. Railway construction projects and scheduling bottlenecks are also a problem. Expanding the rail network is already costing billions, but it's still less expensive than introducing an entirely new means of transport. In some times and in some places, existing infrastructure has even been deliberately destroyed. Los Angeles is one of the most congested cities in the US. The metropolitan region has a population of some 18 million, and the majority of its residents use cars for daily travel. But this wasn't always the case. Through the 1950s, Los Angeles had a streetcar system that was very popular. Tickets were cheap and connections were excellent. People had no reason to buy an expensive car. But in 1961, the Pacific Electric Long Beach line shut down. The trolleys, nicknamed the Red Cars, had been a fixture in the city since 1901. But they were slowly taken out of service after streetcars and the track network were bought by another company. That company didn't want to operate the public transport. It wanted to destroy it. A consortium of car manufacturers, oil barons, and tire companies was behind the move. Without the streetcars, locals had little choice. They had to buy a car. To this day, the car is king in Los Angeles.
You really need to examine each city in detail to see what the problems are there. It also depends on the people who live there. They can have very different needs, even within Germany. But there are, of course, certain basic parameters. Those include the public transportation system and personal transport options that will carry us into the next 50 years. It's not like we'll all suddenly abandon our cars and rely entirely on public transport. There's no one-size-fits-all concept for cities in the future.
Even if it becomes a reality, the Hyperloop will not be a one-size-fits-all concept. It would only be suitable for certain routes and wouldn't replace other means of transport. It would be an add-on, an additional option for a generation that's always online and wants it all. For some companies, that's an appealing business model. During the time that a customer spends in the Hyperloop, there's money to be made. In this model, the customer would not pay for the transport itself, but rather for entertainment during the ride. The main mode of payment would be their own data. Alborn and his team plan to take this model a step further. They want to know exactly where everyone is traveling, when and what their interests are. That information would allow them to deliver a tailor-made experience. But to do that, the passengers would have to give up their privacy.
We have a concept called the naked passenger, which will ultimately provide a seamless passenger experience. When I'm naked, I have no wallet, I have no mobile phone, I'm basically alone. My biometrics would serve as my ID card. I'd use my fingerprints, for example, to establish my identity. So once I have my customer account, I wouldn't need anything else.
Is this the brave new world of transportation? With just a click or a scan, customers get everything they desire, and in return they give up their personal data. The Hyperloop would take the online world and make it part of our physical existence. In the end, this vision is likely to become a reality, and not just for Hyperloop users. Digitalization seems unstoppable. Whether we are ready or not, the mobility of the future looks set to be digital.